Hello everyone, this is Colin here, and today we're going to take on a project that almost every homeowner will have to do eventually, and that's replacing a water heater. Before we get started, let's talk about water heater types and replacement options. What I have here is basically what you'd call a standard model. Standard models usually have two 4,500 watt coils. The coils are usually copper, and the tank is usually either not lined at all, just bare carbon steel, or has a inexpensive liner. What I'm going to go back in with is kind of the significantly upgraded version. They usually have different, different levels of quality, either 2 or 3 depending on the brand, and you have the basic version like this, which usually has a 6-year warranty, and right now it's 2020, costs something about $400. There may be a mid-grade like 9-year warranty type tank, and then there will be a high-end tank that has a 12-year warranty, and the reason for the higher warranty is quality of materials. So the higher warranty tanks, which is what I'm going to replace this with, will have stainless steel coils instead of copper. It won't be a bare steel tank, it'll have a proper fiberglass liner, fiberglass and epoxy liner. And they may have a little bit more insulation on them as well to help with heat loss and energy efficiency. The one I've got also has a bunch of unnecessary bells and whistles like Wi-Fi, and has a water shutoff and leak detection. That part's actually probably useful. So yeah, we're going to go with the high-end one. The high-end ones cost about $600 as opposed to the low end being $400. So when you consider 6 years of performance or 6 years of service minimum versus 12 years of service minimum for a 50%, not even 50% increase in cost, it's a 30% increase in cost. It's kind of a better deal in terms of dollars spent per years of service to get the really good one. Obviously, because I was saying, I'm talking about electric hot water heaters, and I'm specifically talking about the tank varieties. This is a 50-gallon tank. I did consider going with a tankless, but they're more expensive, and I'm in Arizona, so most of the year this thing's sitting in a hot garage and not actually losing that much heat anyway. So we're going to stick with the tank variety. Alright, well, that's enough on water heater design and selection. Let's get to it. Okay, to do this job, you're going to need a few things. You will need a pipe wrench, and either a second pipe wrench or a backup wrench. In this case I used a pair of vice grips. You'll need a pair of screwdrivers, flathead and Phillips. Gloves will be useful, especially for handling hot pipe. And you're going to need rags to clean up water, and a garden hose, which is kind of over there. I didn't drag it in for the shot. To try to get water from the old water heater out to the yard or somewhere where you can drain it to. A bucket of water helps for cleaning up after you're done. A dolly is very useful. I actually use 2 of these, one to get the old one out, and it's still sitting on it currently while it's draining, and one to bring the new one in. An electrical test pen, this is kind of optional. I always check the wires, even though I've turned off the circuit, just to make sure the circuit breaker's been wired correctly. Some of the stuff's going to be kind of optional, the rest of these items. If you have to do any soldering, you'll need a torch, flux, silver, lead-free solder, striker. If you will need some, once again, if you're doing soldering, you'll need some amount of fittings. In my case, you'll see me put several new valves in, and do a couple sweat fit joints. So I cut a bunch of 3/4 inch copper tubing. I had some 3/4 inch fittings. That's going to be kind of on a case-by-case basis, depending on how your particular application goes. You also will probably need some Teflon tape. Again, Depends on your specific piping arrangement. Let's get started. Of course, you also need a new water heater. First thing you have to do is turn off the power to your water heater. These are usually wired in, and they usually have 240 volt electricity. So go to your circuit breaker, find the circuit for your hot water heater, or for your water heater, and then turn it off before you do anything else. Okay, once we've got the power off, the next step is to actually empty the water heater, because you're not going to be able to move it or anything with it full of water, because it weighs too much. This is actually a relatively difficult part of the process. Basic step is you run a garden hose out to your lawn or garden or somewhere where you can put this hot water, and it's going to have to be, it's going to be gravity drained, so you got to make sure it's going downhill or level the whole way. And then you open up your drain valve. The problem is, if your water heater has been in service for any amount of time, and this was true for me, it's probably going to be full of calcium and scale and all that, just, debris in there. So this little valve, which you have to open with a flathead screwdriver, will probably get plugged. So you'll be either cycling it open and closed to try to break up the bits of scale that are plugging it, or, and as you can see from the floor here with all the calcium on it, because I attempted to fix this rather than replace it last weekend, you'll end up having to actually take the drain off completely, which makes a huge mess, but does in fact get the water out. So that's actually what I ended up doing. I had to take the whole valve off completely, and then just shove the garden hose in there as best I could to siphon off as much of the water into the yard as possible and have as little come out here as I could. But even then, I had to actually, it would still plug off, and I had to reach inside the tank opening there and with a finger and shovel out calcium to keep it from blocking off. So this is going to look easy in this video because it's already been mostly cleaned. I did this all last weekend. But the reality is this can be a very time-consuming, challenging part of the project. So don't be surprised if you spend 2 hours trying to get the tank empty. Okay, once you've gotten some flow going out of the hose there, you're going to want to close your isolation valve, because otherwise you're not actually going to get the tank empty. If you have it, you want to open your bleed here, because that will allow air in. Right now we're going to start disconnecting fittings. So we've got 2 compression fittings here for the water supply and hot water outline, and we've got the pressure relief valve here. So I'm going to go ahead and get those disconnected, and then we'll do the electrical connection as well. Okay, now I'm going to do the electrical connections here. And we turned the circuit breaker off, but just to be on the safe side, I'm going to run my little voltage tester here to make sure there's nothing live, because this is 240 volts after all. So it looks like everything's dead, which is good. So we will proceed. Now you got a red line and a black line. I'm going to mark the black line here with a Sharpie so that I know which one's which when I reconnect the new one. Okay, now we just got to get this thing empty and we can get it out of here. Alright guys, well, we had, as usual with plumbing projects, some unexpected surprises. With the water backflowing through one of the mix valves in the house, I had to turn off the whole water to the entire house to disconnect this line. That's not really convenient. Obviously having the hot water out is inconvenient as well, but it's really inconvenient to have all the water out. So I'm going to put a valve on this side, which probably should have been there. So, cutting pipe, pretty straightforward. Get yourself some 3/4 inch copper pipe. In this case, I'm not doing that much. I'm just, I don't want to extend it that much, so I'm just going to cut off a little segment here. This is a, basic tubing cutter. You just tighten it up. Not super tight, just snug, and then start turning, and then as it gets looser, you put a little bit more tension on it. Continue here until it cuts through the tube, which doesn't take very long. Okay, now I'm going to take some flux here, and I'm kind of lazy and old school here. They make paint brushes and whatnot for flux, but I always just grab the end of the solder here and just dab it on with that. This is regular old acid flux. Nothing crazy, nothing fancy. Get it from the hardware store. The solder here, because this is piping for drinking water, is lead-free silver solder. So there are different kinds of solder. You can get metalworking solder and such, which does have lead in it, which is fine for metalworking, but you don't necessarily want that in your drinking water supply. So make sure you're using the right kind of solder. Okay, so the trick, if there is such a thing, to soldering a fitting like this is to, you got to get it hot enough to melt the solder. But that usually, copper's pretty conductive, so that usually happens fairly quickly. So it's not about, especially with a wall fitting like this, it's not about gradually heating it up. It's more about just getting it to temperature quickly. And most of these like pen type torches aren't super hot, so usually you can be pretty aggressive on the heat setting. Actually, I had a little bit of water trapped in there, in that pocket, which was obviously holding up the show there. So I just drained it out, and looks like we are going to be free here in a second. There we go. And then while it's hot, get the threaded fitting set up here. You'll see you put solder on the top and it just runs all the way along and inside the threads on both sides, and that's eventually it'll drip off, which I guess is slightly unprofessional, but I'd rather have a little bit too much solder than not enough. So this guy is still hot. We're going to solder onto one end of the pipe, and then we're going to, oh good, that's going to go in easily, save me some misery. And then we're going to solder the threaded fitting on the end of that. I'm sure there's a professional plumber somewhere out there just watching this and cringing and going, that is the ugliest solder joint, the ugliest sweat joint I've ever seen. And he's probably right. Alright. So that is a ugly but hopefully sound solder joint. We're going to let it cool off for a bit here and get some Teflon tape on it, and then we'll water test it. Okay, now we're going to get some Teflon tape on these threaded fittings. If you're not familiar, with Teflon tape. You can also use pipe tape, but I kind of like Teflon tape better. When you put it on, it is directional, so you want to make sure that, if you're screwing something in, for example, you're going to go to the right. You want to thread in the opposite, in that opposite direction, so that you don't unwind the Teflon tape that you've put on there in the process of threading the fitting into where it's going to go. Right, well, let's put it all together. Alright, I've threaded my wall fitting. I've put Teflon tape on wall fitting, and now I've got a 3/4 inch ball valve, so we're going to get this guy put in. Okay, that looks good. Get the ball valve in, and we're going to close it. Okay, now we're going to test our first piece of handiwork here by turning the main water on. And if we did a good job, nothing will happen. If we did a shit job on this sweat joint, you'll see water spray everywhere, and I'll have to run around and turn it off real quick. Okay, well, there's nothing spraying out. Let's grab get our grubby mitts on it. I don't see any water. I got a little flex left, but looks like we got it. We are in business. So, sweat joint number 1 appears to have been a success. Okay, well, I'm still doing things in the meantime while I'm waiting for the old water heater to drain. So, this is one of the last things I can do. This is the PSV, and obviously has a PSV connection on the other side. I couldn't pull the old nipple out. It was, way too stuck in there, so I just bought a new one. This is just, cast iron. This PSV, should never lift, so this is technically not really a wet fitting. So this is one spot where you can actually save a buck or two and not buy a brass or copper fitting, and you can just buy a cast iron one. Depending on how yours is arranged, if you don't have the drain going out the wall like I do, and your PSV was just kind of sitting there, you might want to pipe that to grade or to a bucket or something, because these do occasionally start leaking, and when they leak, you end up with water everywhere. So you definitely want to have that routed to a good location. Okay, well, this is still draining, but I'm not going to wait any longer. I'm going to kind of struggle it out of the way here, so it's off to the side, and so it can continue draining while I get the new one in here. Okay, well, now that we've got the old water heater out, and it's currently out in the front yard. I took the valve assembly out completely, so it's still draining into the yard. Now we're going to clean up the mess, in part because you're not going to get another opportunity to do this, and also because my new water heater has a bunch of sensors on it for detecting leaks, and if I've got a bunch of water here, it's going to think it's leaking and shut off as soon as I try to turn it on. Okay, now that we've got our old one out of the way, our floor is clean and dry, we're going to roll in the new one now. Okay, as you may have noticed, the new one's quite a bit wider than the old one. That wasn't an accident. The old one's, I guess, a quote-unquote older style. Now, presently, they do two styles, a short variety and a tall variety. This is the short variety, 50 gallon. The tall variety would have ended up somewhere over here in terms of height, which would have obstructed my valves and such. So I went with the short one, which is even wider than my old one, but at least affords me the advantage of not having to redo all this plumbing. So let's start connecting things. Okay, let's get these last few fittings hooked up here. If you're looking at this and saying, hey, this looks a little different than it did before, you're right. As you probably noticed, this flexible copper coil fitting here wasn't able to reach where it needed to connect, so I had to take this assembly off, solder in a 90 and about a foot or so of straight pipe to give me enough reach to get there. With everything connected, the next step before you wire it up is to test your fittings. So we're going to turn the cold water on here and hopefully nothing will leak. We got a little bit of bubble in there. Let me tighten that guy up. Okay, the next thing we're going to do is go open some hot water taps in the house. We're going to open this up as well. This is your hot water. And right now we've got a whole big pocket of air in the top here, which we need to get rid of before we turn the heater on, because otherwise you can burn up a coil. So we're going to go turn on some hot water in the house and flush all the air out. Okay, well, that seemed to work out all right. I just went through the house and opened up a bunch of hot water faucets, blew all the air out, and everything there seems to be pretty good. Let's just do one final leak check here, make sure everything out here is holding up all right. Okay, now we're going to get it all wired up here. So we've got our piece of conduit and the same wire nuts we used before, and it looks like I can even just leave this thing on here and go that way. So let's pull this one off, and we got hot neutral on the ground, and it looks like there you go. Okay, work. So the one we marked with our Sharpie here is going to go to the black one, and the other one goes to the red. Okay, we're all wired up now. This should be good to go. It's full water. We got no leaks. We're fully pressurized. Basically, the short answer is it's time to go and turn the power back on. So we're going to go out to the circuit breaker and do that. Alright, well that's all there is to it. We're powered up. I turned the Wi-Fi on this thing on and went ahead and programmed it. It seems to be working, so that's all I got for today. Thanks for watching.